Hello everyone, welcome to the channel. So in this video, I'm going to show you how to perform a georeferencing in ArcGIS Pro, a beginner's tutorial. So let's get started. So now let me explain about what is georeferencing. So georeferencing is typically involves taking a non-spatial data such as a scan map or aerial photograph, satellite images, or even the textual descriptions and aligning them with the real world coordinates. This allows this data source to be accurately positioned and displayed within a common spatial reference system. So georeferencing is crucial for a wide range of applications such as creating an accurate maps, digitizing paper maps, analyzing remote sensing data, and overlaying different data layers for spatial analysis. It allows this geographic data to be integrated, analyzed, and visualized effectively within a GIS environment, making it a fundamental process in the field of geospatial technology. So now let me get back to our ArcGIS Pro. So in the table of contents section, we have two different base maps. One base map represents a world topographic map, and the second base map here represents the world hill sheet. So now let me show you the topo sheet. We're going to georeference. So this is the topo sheet we're gonna georeference. Currently it is not georeferenced, so we're gonna use this topo sheet. So this particular topo sheet is provided by the Survey of India. So we're gonna digitize this particular topo sheet. So now let me add my topo sheet into ArcGIS Pro. So for that, we're gonna move on to the section called Catalog. So Catalog section is available in the view, and click this option called Catalog Pan. So once you press this, the window Windows pops up saying Catalog. In that, we're gonna navigate to my folder containing my topo sheet. So in that, I'm gonna add my topo sheet that is in TIFF file format. I'm gonna add the topo sheet in TIFF file format into our ArcGIS Pro. So now let me click this and drag into our ArcGIS Pro. So once you did that, the window pops up saying build a pyramid and calculate statistics for this particular topo sheet in TIFF file format. We're gonna click OK. So once you did that, the topo sheet is currently added to our ArcGIS Pro. So you can able to visualize here the table of contents section. Our topo sheet is available. So in case if your topo sheet is in PDF file format, you can navigate to your conversion tool. In that, you can use the conversion tool called PDF to TIFF, and you can add your PDF file into that. You can convert it to a TIFF file format, and later you can add this TIFF file format into our ArcGIS Pro. And the link will be given in the description to how to convert a PDF to a TIFF file format. And you can able to saw the message once we have added our raster file. It is currently in unknown coordinate system. So now let me right click and zoom to the layer. So now it is currently in unknown coordinate system. So basically it means that it is not georeferenced. And also let me show you one more thing. You can add your data either using catalog, or also you can move on to this option called maps. In that, we're gonna select this option called add data. In that, we are gonna select this add data to the map. So in that, we're gonna navigate to our folder location of our TIFF file format of our topo sheet. So now let me click this and add this. Click OK. So once you did that, so here you can able to visualize unknown coordinate system. The map data source is missing, coordinate system information. So click here to view details. So now let me remove this particular. So currently it is an unknown coordinate system. So now let's start our georeferencing. Now let us take a look at this topo sheet. So in the topo sheet, the both latitude and longitudes is provided in all the four corners of this topo sheet. So you can visualize that. So the latitudes and longitudes are provided in the topo sheet in all the four corners. So now what we're going to do is we're going to assign this coordinates, the real world coordinates for this particular topo sheet. And now let us take a look of this projection of this topo sheet. So we can able to visualize the projection is in UTM 1984, that is WGS 1984. So this particular topo sheet is in Karnataka, so it lies in projection UTM zone 43 north. So now let me zoom out. So now go to this option called. So now we have to move on to the option called imagery. So in that, you make sure that you select your layer, that is your topo sheet. Select this layer. Once you select, the option called georeference will pop up. So click this option called georeference. So in that, first we have to move on to this option called set SRS, that is set coordinate system. So click this option. So in that, the currently our topo sheet is an unknown reference system, that is unknown coordinate system. So now we're going to select our coordinate system. So go to the geographic coordinate system. In that, we're going to select this coordinate system called WGS 1984. So move on to it, click this option called world. So in that, we're going to select WGS 1984. So this is our coordinate reference system, that is WGS 1984. So click this and now click OK. So once you did that, now let me zoom out. So it is get projected somewhere in the world. So now we have to go to this option called, we have to turn off this option called auto apply. So after that, we have to move on to the option called add a control points. So control point is useful. So in order to project our topo sheet in a right coordinate system, so for that we're gonna use this particular longitude and latitude. So we're gonna add control points over this point, and now we have to provide our longitude and that is our latitude and longitude. So for that we have to place our control points. So make sure that you select this option called control points and place a control point in the intersection between our latitude and longitude. So this is our longitude 75 degree and 0 minutes, and similarly our latitude is 15 degree and 15 minutes. And now let us add a control point between the intersection of our longitude and latitude. So this is the intersection, and right now we're gonna in the mouse you have to click your left click and right click. So once you did that, a window pop up saying target coordinates. Here the X represents our longitude and the Y represents our latitude. So the currently longitude it is in 75 degree and 0 minutes. So now we have to open a browser. So I have opened a browser and entered as a calculator to search in Google. So we receive a calculator here. So now we have to convert our degree, minutes, seconds to decimals. So for that, so now we have seen our, it is 75 degree. So in that we're gonna add plus symbol and 0 minutes. So plus 0 divided by 60. So 0 minutes divided by 60, and we're gonna add this plus sign again, plus. So in case you have a seconds, you can add a seconds. So I don't have any seconds in the here. So for now I'm gonna add a 0 here. Let me add a 0 divided by 3600. So to convert from degree minutes to second, that is from degree minutes to second, to convert to a decimals, we are using this formula. You have to add your degree and your minutes divided by 60 plus your seconds divided by 3600. So now click this option. So once you did that, your longitude in decimal, as you can view the result here. Now we're gonna paste this value in our ArcGIS Pro. So here I'm going to place my value, that is 75. So I have placed my value 75. So similarly we have to convert our latitude, that is 15 degree and 15 minutes. So let me go to the calculator. So it is 15 degree and 15 minutes. So 15 plus we have to add our minutes. It is in 15 minutes divided by, it is 60, and plus we don't have seconds, 0 divided by 3600. So this is the formula to convert from degree, minutes, seconds to a decimal. So now click this option. So it is 15.25. So now let me get back to our Pro. So here I'm going to type as 15.25. So now I have typed as 15.25. Now click OK. So once you did that, a control point has been added in this intersection. Now go to the layer, right click and zoom to the layer. And we are moving to the next point here. We're going to add another control points. So we can add a control point here. let me place a control point, that is left click and right click. So we're gonna add here our longitude here. It is 15 degree and 15 minutes. Now go back to our calculator. So it is 15 degree and 15 minutes. So let me place 15 degree plus 15 minutes divided by 60 and plus, so in case you have a seconds, you can add 0 divided by 3600. Make sure that you remember this formula to convert from degree, minutes, seconds to a decimal. Now click this option. So it is 15.25. Let me get back to our Pro. So here X represents longitude and the Y represents latitude. So we have this is our latitude. So now let me place 15.25. So now I have placed my latitude value of 15.25. Similarly, the longitude is 17 degree and 15 minutes. Now let me get back to our calculator. So it is 17 degree and 15 minutes. So 75 plus 15 minutes divided by 60 plus, again add your seconds. So it is 0 divided by 3600. So now click this option. So it is 75.25. Now let me add my value in the longitude section in X coordinate. The longitude value in X coordinate, that is 75.25. So it is 75.25. Once you did that, you can click this option called OK. And now another control point has been added. So let me add this, go to the option, zoom layer, and we move on to this towards our third intersection. So we're going to add a control point here. So to project our topo sheet, a minimum of 4 control points is required in the 4 corners of the topo sheets. So now let me place my third control point here. We have to left click and right click. So here the latitude, it is a longitude now. X represents longitude and Y represents latitude. So longitude is 75 degree and 15 minutes. So let me add my values here. So longitude value is 75.25 as a decimals. So 75 degree and 15 minutes is converted to a decimal of 75.25. And similarly, and latitude will be 15 degree and 0 minutes. Let me add this value here. So you're going to convert this 15.0. It is our decimal. So click OK to add our third control point. And now similar to zoom to layer, we're going to add our last control point here. Make sure that a minimum 4 control points is necessary to project your topo sheet. So in the 4 corners of this topo sheet. So now we're going to add a fourth control point. So we zoom to this point of this point. So 75 degree 0 minutes. This is our longitude, and 15 degree and 0 minutes. This is our latitude. So left click and right click. So longitude will be 75.0. And the latitude will be 15.0. And now click OK. So now we have added 4 control points. Now right click, zoom to the layer. So now let me show you the formula. So here degree, minutes, seconds to decimal conversion. So this is a formula: degree plus minutes divided by 60 plus seconds divided by 3600. This is the formula to convert degree, minutes, seconds to a decimals. So now let me get back to our ArcGIS Pro. So once you added your control points, you have to click this option called apply. So basically this option is applies the pending control points edits to transform the source layer and update the display. Now click this option. Now let me go on to that particular location here. So we have to move to this layer, right click and click this option called zoom to the layer. So now we have so once we added our control points, so now let me zoom into this part of the study region here. So here you can able to visualize here a water body. It has been shown in this topo sheet. So now let me turn off this topo sheet. So now you can able to visualize the base map here. The water is being clearly highlighted in the base map and similar to the topo sheet. And now let me move to other part of the study region here. So you can visualize another water body here. So now I can visualize it more clearly. So now let me turn this layer. Let me turn off the topo sheet. So here you can able to visualize in the base map. So I can visualize the water body here. Let me turn on, and turn off. And now suppose if we want to make some changes to this control points or to delete the control points, so you can move on to this option called control point table. So click this option. So in that you can select any control point of your choice. Suppose if you want to make change or to add a control point, you can click those particular control point, and you can go to this option called delete selected. You can do that. And suppose if you want to delete all the control points, you can click this option called delete all. So now let me close this. And now suppose if you want to save this file, you have to move on to this option called save. So it automatically georeference this raster dataset. So you have to just click this option called save. So you have to click this option called save, and suppose if you want to save as a new file, so to create a new raster dataset with the georeference transformation applied, you have to click this option. You can save it as a new file. So once you did that, so here a window pops up saying export raster. So you can choose your output raster dataset, and now choose your output raster dataset. You can click this option to choose your folder location here. And now let me select this. Now enter the name as a georeferenced. So I have entered as georefer topo, and click this option called save, and you can choose your coordinate reference system here. So you're going to select your geographic coordinate system. In that we're going to select this WGS 1984. So you're going to select this coordinate system called WGS 1984 and click OK. So once you did that, and now choose your output for output format. So let me select as a TIFF format. So once you did that, you can click this option called export. So click this option called export. So once you did that, you can also use another method called, you can just save this layer. So you can update your georeferencing transformation of the source raster dataset. So once you did that, the georeferenced raster dataset will be saved to your folder location. And now we're going to turn on this layer, turn off this, and you can check for the accuracy of this topo sheet. So you can so now let me move on to this water body here, and let me turn off this layer. So we can visualize the water body. And now let me move on to this water body. Let's check for the georeference. Yeah, it is correct. And now let us convert this our topo sheet to a projected coordinate system. So for that, because in geographic coordinate system we cannot measure area. So to calculate area, or to suppose if you want to find the area of this particular water body, you have to convert to GCS to a PCS, that is projected coordinate system. So it is lying in the zone UTM zone 43 north. So this particular study area is lying in Karnataka. So you can able to visualize that. So now let me show you this. So the world UTM zones are classified into 60 UTM zones. So in India, the UTM zones lying from 42 to 45, 42 to 45 or 46. So specifically our study areas lying in Karnataka. So you can visualize here the Karnataka. This is a Karnataka state. So it is lying in UTM zone 43. So you can visualize here UTM 43. So now let me get back to our ArcGIS Pro. So to convert to a projected coordinate system, so go to this layer called GeoRefer Topo. So right click, and that you're gonna select this option called data, and click this option called export raster. So in the export raster, so we have to in this option output raster dataset, choose the output file location. So we're gonna save GeoRefer Topo PCS and save it. Once you did that, choose your coordinate reference system. So select this option. So in that we're gonna select the PCS, that is projected coordinate system. In that we're gonna move on to this option called UTM. In UTM we're gonna select WGS 1984. So we are in northern hemisphere. and study area is lying in northern hemisphere. So we're going to select UTM zone 43 north. So now let me select that file. So UTM zone 43 north, WGS 1984, UTM zone 43 north, and click OK. Once you did that, so we move on to our output format. So select the output format as TIFF. So I've selected the output format as TIFF. So once you've done that, we're going to select this option called export. So it's going to export our topo sheet to a PCS. So it is building from it. And now our file is available here, the georefer topo PCS. It's available here, so you can able to visualize it. So after converting to a PCS, that is projected coordinate system, you can calculate area using this topo sheet. And now we can check this. So we can check to a part of this water body. We can zoom to this water body area, and let me turn this off so you can visualize it. So we have correctly projected our topo sheet. So we have used our topo sheet of to georeference it and convert it to a GCS. So after converting to GCS, we have converted it to a PCS. So let me show you the difference between these two layers. So this is our geographic coordinate reference system. Right click, go to the properties. In that, we're going to visualize the spatial extent. So here the spatial is in geographic coordinate system, and the angular units are in degrees. So in degree we cannot measure area, so we cannot calculate area here. So now let me cancel this and go to this layer called georefer topo PCS, that is projected coordinate system. Right click, go to the properties. So here you can visualize a spatial reference. It is in projected coordinate system of WGS 1984, UTM zone 43 north, and the linear unit is in meter. So now you can calculate areas using this particular topo sheet. So now let me close this. So in this video I have shown you how to georeference our topo sheets in ArcGIS Pro. So thanks for watching, and please subscribe to our channel and give us a like.